In about 3 minutes, Flight Director Jason Willis will poll each one of the subsystem engineers and the flight controllers to make sure that all systems are still go for entry.
Flight Telecom.
Go Telecom.
I'm seeing about 28 dB PC over and 0 on both receivers. We expected a half dB increase for the back shell low gain antenna, and I think we're seeing it.
Copy that. Thank you very much, Telecom.
Flight Director.
Hold one. Go EDLCom.
D, the tone Excel 1. We have received that tone for 31 seconds.
Copy that. We have received Excel 1.
The Excel 1 tone being transmitted by a spacecraft is an indication that the spacecraft is not yet decelerating. Since we have not hit the top of the Martian atmosphere, this is indeed the intended result. The ruffling that you are seeing in the Mission Control Center is that the flight team is now opening their good luck candy packets supplied by the BISTers.
All stations, this is Flight. It's time for the pre-entry poll. ACS.
ACS shows us in sunline rate control. The last update had 0.69 degrees of pointing error, a nutation of 0.34 degrees, and the IMU quaternions are in good agreement with that.
Copy. Thermal.
Flight, you've been kept well abreast of the events that were unfolding here. We expect, again, gas generators on the last packet. We got to peak out at minus 0.5 degrees C, half a degree C below the max allowable limit. Venting successfully occurred, 2.9 psia on the pressure, and the RBAW, the rover battery, temperature going up to 2.6 degrees C. We believe that indicates that the 0 degree heater did in fact come on.
Copy that. Power.
Yeah, the power system is nominal. The bus voltage is 32.3. The both battery volts are still high, indicating they're not discharging. The lander battery current is at 3.28 amps, and the cruise flow rate current is at 5.88.
Copy
Everything
that.
looks as expected.
Copy that. Fault protection.
Fault is nominal.
Flight software.
Flight software is nominal.
ACE.
Both 70 meters, both prime and backup receivers are in lock, and all 34-meter receivers are in lock on carrier only.
Copy that. Telecom.
The signal levels at Station 14 are as expected. They are averaging about 28.5 dB, and the bandwidths of the receivers are 15 hertz on receiver 1 and 10 hertz on receiver 2.
Copy that. EDLCom.
We are ready.
Copy that. LMA.
Goldstone and Canberra have settled lock on the MGS downlink. We continue to receive real-time health and status and PDS telemetry. MGS is ready to begin recording the ADL data on the SSR-1A. Spacecraft health remains green, and MGS is ready.
Copy that. MGS Mach.
Flight Mach telemetry is all nominal, and we show the beginning of the global map acquisition as expected, and we are ready at this time to start collecting EDL data.
Copy that. Nav.
Flight nav is still receiving one-way Doppler on the XR display, and we are nominal.
Copy that. MDOT.
MDOT is nominal.
Copy that. Mission flight.
Flight.
All subsystems are reporting ready for EDL. Both primary and secondary complexes are configured in green. MGS is green, and Mach is ready to record.
Copy that. Thank you, Flight.
Flight Director Jason Willis reporting that all systems are go for entry, descent, and landing. We are currently 6 minutes away from hitting the top of the Martian atmosphere. And a pleasant good evening from the flight deck of the Spirit. At this time, we are roughly 11 minutes 48 seconds from landing at the Gusev crater in the southern hemisphere of Mars. Just as a reminder, during the descent through the atmosphere, the vehicle will not be transmitting data due to the unfavorable orientation of the antenna relative to the Earth. However, the spacecraft will be transmitting simple electronic tones called semaphores. These tones will vary through the course of the descent depending on the condition that the vehicle encounters. Tonight, we'll be flying into our landing site on a path slightly north of east at a heading of about 75 degrees. Our current speed is 11,320 miles per hour, which is fast enough to traverse a distance equal to the United States in 12 minutes. We are expecting that the weather today at the landing site to be fairly mild, with temperatures averaging about minus 15 degrees C. We are expecting, or at least our computer models show that we should expect 13 knots of crosswind at the time of landing, blowing to the southeast with potential for gusts up to 40 knots.
For those of you who haven't already punched up EDL commentary, I would suggest you do. Just to give you a quick brief on the displays. The left-hand display is the current state of events, and will stay up throughout. The right-hand display will show you the left-hand window in the right-hand display shows the PT over and not, essentially the received power we're getting from the spacecraft, and the one on the right shows the Doppler residual or sky frequency, and that'll change so that we can go through and best detect in real time the parachute entry and parachute deployment. With that, I'm going to go ahead and give the nets over to Paulie Robb, and MGS Mach go ahead and chime in as necessary.
And again, we have the potential for gusts at the time of landing up to 40 knots. And finally, for your pre-entry briefing, if Mars had an Earth-like calendar, today would be February 19th on Mars. Local time at Gusev crater is now approximately 2:15 p.m. For those of you scientists out there ready to explore Mars, now would be a good time to set your watches. And on behalf of the entry, descent, and landing team, it's been a pleasure having you guys on board. Best wishes for a successful science mission. At this time, we'd like to invite you to sit back and enjoy the landing. Now roughly 3.5 minutes from entry into the Martian atmosphere. Current altitude 289 miles. Current velocity 11,640 miles per hour. We are currently 1,076 miles uprange of the landing site.
And looking into mission control right now, we have some visitors. NASA Administrator Sean O'Keefe. Next to him, Dr. Charles Alachi, JPL Director. Next to Dr. Alachi, Dr. Ed Weiler. He's the Associate Administrator for Space Science.
Basis display.
Two and a half minutes to atmospheric entry. Current altitude 220 miles.
Flight Ace.
2 minutes to atmospheric entry, current altitude 185 miles.
Ace.
Could you pass on those reports that you're getting from the stations? We had a glitch.
Yeah, at minutes 26:18, they had a momentary glitch on the 70 meters. The 34 has also experienced it, and they're attempting to reacquire. And the 34 meters are reacquiring as we speak.
Copy that.
Just under 90 seconds to atmospheric entry, current altitude 152 miles.
Thank you.
Flight was checked.
Copy you. Ace flight.
Flight Ace.
Respond to 3-4, please. Could you confirm the time of the outage?
Yeah, they had a momentary glitch at minutes 2618.
2618, thank you.
We have just passed 1 minute to atmospheric entry, current altitude 121 miles, current velocity 12,084 miles per hour. Signals from the spacecraft indicate the vehicle is accelerating as expected.
Flight, that glitch was expected on the DTTs
Copy that.
due to the predicts.
30 seconds.
Thank you, Polly.
Flight MGS Mach.
Go NGS Mach.
Our telemetry shows that we have begun receiving MR data, or at least we've switched into receptivity mode.
Copy that. Receiver is on and ready to receive data.
Copy that.
Atmospheric entry
Entry in 3, 2, 1.
The vehicle has now hit the top of the Martian atmosphere. However, the velocity will continue to increase for the next minute as the thickness of the atmosphere at this height of an altitude is not sufficient to slow the vehicle's fall. We are now at an altitude of 73 miles, moving at a speed of 12,192 miles per hour. Downrange distance to landing site is 437 miles. We will be awaiting confirmation for the spacecraft via these electronic tones that the spacecraft is indeed decelerating. However, we do not expect to see these tones for roughly...
Flight nav.
Go nav.
The one-way Doppler and the interferometric narrowband spacecraft Doppler indicate that atmospheric deceleration is occurring.
Copy that.
Navigation team reporting that they have detected entry into the Martian atmosphere. Time is now approximately 1 minute after entering the atmosphere. The vehicle is at an altitude of 46 miles and will now begin to slow down as it drops into the lower and thicker parts of the atmosphere. Current velocity is 12,175 miles per hour, which is 27 times the speed of sound. Telecom reporting that the entry is slightly on the shallow side. This is a nominal condition. The next event to occur should be the peak heating, which will occur in about 15 seconds. At the time of peak heating, the air flowing by the capsule will cause the heat shield to be heated to temperatures upwards of 1,600 degrees Celsius. If all the energy absorbed by the capsule could be converted into electricity, it would be enough to power 2,000 homes simultaneously. However, the vehicle's protected heat shield will...
detected XL2 tone.
XL2 tone has been detected, indicating that the vehicle is reporting that it is decelerating at a greater rate, greater than 1 G.
Detected XL3 tone. Flight.
Currently, we expect maximum deceleration in approximately 6 seconds. We should be decelerating at a rate of 5.9 Gs.
Detected XL4 has been detected.
Vehicle reporting that is decelerating at a rate between 3 and 4 Gs. There is some time lag between the reporting and the predicted telemetry.
Flight, we've detected XL tone 5.
Currently 2 minutes 21 seconds.
Flight, we detected flight tone 6.
XL tone 6 indicating vehicle has decelerated to a rate between 5 and 6 Gs, which is the maximum expected value. Currently 2 minutes and 30 seconds after entering the Martian atmosphere, current altitude 16.5 miles. We should now be decelerated at a rate of 3.9 Gs. We should have passed the point of maximum deceleration. Current speed 4,000 miles per hour.
Flight detected flight tone 5, acceleration tone number 5. We're coming back down again.
Copy that.
Spirit lander reporting that we are decelerating as expected. Current rate of deceleration on board spacecraft is expected to be 2.4 Gs.
Flight detected acceleration tone number 4.
Copy that.
We expected parachute deployment should occur in roughly 60 seconds. At this time, the onboard computer is busy looking at the vehicle's rate of deceleration to determine the proper time to deploy the parachute. This will occur about 1 minute from now once the vehicle is slowed to 1.7 times the speed of sound.
Flight detected flight acceleration tone number 3.
Vehicle decelerating nicely as expected. Over the next minute, the vehicle's rate of wobbling will gradually increase. This is a natural consequence of passing through the atmosphere at low supersonic speeds. Now, 3 minutes, 35 seconds after atmospheric entry, just under 30 seconds to expected parachute deployment. Current altitude, 45,000 feet. Current velocity, 1,356 miles per hour. Our current rate of deceleration is 1.1 Gs.
Flight detected acceleration tone number 2.
1.0 Gs. Expected parachute deploy in 10 seconds. Expected parachute deploy in 5 seconds. 4, 3, 2, 1, mark. We're awaiting confirmation the parachute has deployed. Current altitude should be approximately 25,000 feet. Velocity 446 miles per hour. At this time, we expect the vehicle has gone subsonic, moving at a velocity of Mach 0.6, 304 miles per hour.
We see parachute detected.
Telecom reporting the loss of lock followed by the rapid reacquisition indicates the parachute has deployed at near the expected time.
Flight nav.
Go nav.
The one-way Doppler has stopped being received, indicating that the PVR has lost lock, which is consistent with parachute deploy having occurred a little bit later than the predicted parachute deploy time.
Copy that.
Navigation reporting the parachute may have deployed slightly late. However, there's a 10-second uncertainty on this value. So
Reading heat shield deployed event.
Spacecraft reporting that heat shield has indeed jettisoned.
Lander separation event has been detected.
Spacecraft reporting lander is separated. We expect that radar will lock on the ground in approximately 5 seconds from now. Current altitude 8,000 feet. Moving at a speed of 173 miles per hour. We are near our terminal velocity. We expect that airbag should inflate approximately 25 seconds. The retro rocket should ignite in approximately 20 seconds from now.
We have resolution 17. That is confirmation of
spacecraft is
radar in lock.
Spacecraft reporting that the radar is in lock and we have a good solution on the ground.
Radar is working.
Expected retro rocket ignition on my mark. Mark. Awaiting confirmation from the spacecraft that retro rocket ignition has occurred. At this point in time, we should be on the ground. We are now roughly 10 seconds from the latest expected landing time. There is a dispersion landing time of plus or minus 30 seconds. So the latest expected landing is expected 3 seconds from now. So roughly any signal that we receive from now indicates the vehicle would be alive, on the ground, and bouncing. Stand by. Now 6 minutes, 37 seconds from atmospheric entry. Still awaiting signal that we are on the ground.
We got 6 signs of bouncing on the surface. It's possible.
Hold that. We have possible signs
we
that
got a green one.
on the surface. Strength of signal indicates we are bouncing on the surface of Mars. This is a very good sign.
Hang on, everybody. Please be quiet.
Stand by. Signal strength is currently intermittent.
We don't see a signal at the moment.
Right.
No signal at the moment.
We saw an intermittent signal that indicated we were bouncing. However, we currently do not have signal from the spacecraft.
Please stand by.
Stand by. We currently do not have signal from the spacecraft. Remember that bouncing and rolling is an event that could occur for another 10 minutes. The spacecraft has to survive all the bounces for landing to be a success. We currently do not have confirmation of signal. The current status is that we had momentary signals after the landing event was expected to occur. We currently do not have a signal from the surface of Mars. We are currently looking at the telecom displays to try to reacquire the signal. Now, 8 minutes, 39 seconds after landing, we expect that the vehicle should bounce and roll for another 7 minutes. The vehicle could bounce and roll for up to a kilometer away from its initial impact point. Still awaiting confirmation of signal.
Flight Director?
Go EDL com.
Canberra EDA is now, just to remind you, is doing 1 second processing, so its noise floor is very high. You can see it's not able to see anything lower than about 13 dB hertz. We, in about a minute or two, will begin doing longer integration times. That will drop the noise floor down. We may see something at that time. So this could be just an artifact of the way we're processing at the moment.
Copy that, EDL com. MGS Mach. This is flight on MER-A ops. MGS Mach, this is flight on MER-A ops.
Go ahead, Flight.
Can you give me a current status, please?
We are not quite yet able to say just how much data volume we're getting. Stand by, and I will let you know ASAP.
Copy that. Thank you.
At this time, we are 13 minutes 48 seconds after entry into the Martian atmosphere, approximately 8 minutes from expected touchdown point. We currently are still searching for a confirmation for a signal from Mars.
Flight MGS Mach.
Go MGS Mach.
I have some indication of greater than 240 kilobytes of MR data at this point, which may be indicative of reception after landing. We'll have to wait about another 4 minutes to get this data back down.
Copy that. Once we get the data down, we can confirm how much of that data is actually post-landing.
This time we're approximately 10 minutes after landing. The vehicle should have rolled to a stop by now. The Deep Space Network stations at Goldstone and Canberra are still searching for the signal. This is not necessarily
on 3 minutes to first tones from the RLGA, and we're 7 minutes from the tones on the PLGA.
The fact that a tone has not yet been received is not necessarily cause for alarm, as during the bouncing and rolling event, it is extremely difficult to send signals back to Earth, and that there is sophisticated software being used here in the Flight Control Center to process this data. However, it takes the computer some time to catch up due to the intensity of the numerical computations to search for the signal. In roughly 3 minutes, the rover should transmit one of the electronic tones, indicating that it is safely on the surface. Now just over 2 minutes from expected transmissions of tones from the surface.
Flight MGS Mach, I have positive confirmation of more than 240 kilobytes of MR data.
Copy that.
That was Mars Observer Camera Principal Investigator Dr. Mike Malin reporting that it is likely that the Spirit lander successfully transmitted data to the Mars Global Surveyor spacecraft during descent.
MGS Mach, this is flight.
Standby 1.
Copy.
now approximately 1 minute from expected transmission of semaphore tones from the surface. The Deep Space Network tracking stations are still searching for the signal. Again, as mentioned earlier, it requires a lot of computer time to process these signals due to their weak nature, and also the fact that the Earth is currently setting as seen from Mars.
Flight MGS Mach.
Go MGS Mach.
I have 16 frames in lock, receiver in lock. Earliest is at 04:24:57. Latest is at 04:28:57, which is considerably after the expected landing time. I'm still waiting to get the second chunk of data. Standby.
Copy that. Let us know when it's in the queue to get the JPL.
Copy, absolutely.
Dr. Mike Malin reporting that the Mars Global Surveyor spacecraft may have received data from the Spirit lander after our expected landing time. That would be a very good sign. As a point of interest, during the entry, descent, and landing sequence, the Spirit lander reported back to the Earth that it believed that its drop velocity towards the surface was approximately 65 meters per second, and that the horizontal velocity was less than 10 meters per second.
Verify the broadcast channel that the UHF data will come out on, please?
The broadcast channel for the UHF real-time data is MER-A TIS-B4. UHF recorded is MER-A TIS-B5.
Copy that. All stations, this is flight. Station calling flight.
That was me, probably, flight. I have confirmation from Stanford that they saw the signal from the rover for up to 12 minutes.
Copy that.
I mean, they said a couple minutes. They're not very accurate in their timekeeping, but they saw it for a lot longer than it would have been just the descent part.
Copy that. Thank you. All stations, this is flight. Please switch over your DMDs and prepare for UHF data on MER-A TIS-B4.
UHF tracking antenna at Stanford University reporting that it may have seen a signal from the rover at a time at which the rover should have been on the ground. Deep Space Network tracking stations in Canberra and Goldstone are still searching for the primary signal.
We see it. There it is. We have a very strong signal, flight.
Okay, EDL mission, EDL mission.
Okay, all stations.
All stations.
All stations.
Please include everybody.
Flight MGS Mach.
We appear to be on the With we have a very strong signal from the rover, low gain antenna.
All stations, 8. All stations, this is Flight. We have UHF data coming across on B4.
Flight MGS Mach.
Go MGS Mach.
I assume you see your data on the DOM?
Thank you very much, and this is beautiful.
Preliminary indication shows that we had 29 frames in lock, receiver, synchronizer, and Viterbi. The earliest was at 04:24:57. The latest was at 04:32:25.
Well, very good.
See no tones, EDA.
We still have a very strong signal, however.
Flight Ace 14 has carrier in lock.
We have carrier in lock. We have a lock on the signal. Goldstone has the carrier signal in lock from the rover. Electronic tone sent from the rover indicates that the rover has landed base pedal down, which means right side up.
The airbags are still inflated, however.
The airbags, however, are still inflated. We expect that the airbag retraction should start in approximately 2 minutes from now.
Thermal, power. Can you confirm that you're running your plots?
Yes, we are confirming that.
Okay, yeah, this is power flight. Yes, we're doing that right as we speak.
Radio science, flight director.
Go.
Radio science sees the 1 kilohertz tone, the vestigial tone.
Copy that. Thank you, Polly. Power and thermal, please let me know when you've got your plots.
Copy that.
And so after a few tense moments there, it appears Spirit has indeed landed. With me right now is Director of Planetary Flight Projects, Chris Jones. Chris, walk us through what happened just the last 15 minutes or so.
Well, let's see. We did entry, descent, and landing pretty much by the book. The separation was just as expected. It occurred at the time we expected it. We saw the brief outage when that separation occurred, and the DSN locked up right away. The deceleration through the atmosphere was very visible on the screens that we saw here. You could really see the atmosphere working on the heat shield, taking us from 12,000 miles per hour down to about 1,000 miles per hour. We saw the heat shield deploy. We saw lander separation. We saw the radar turn on, and we saw it get the proper solution for how far the lander was from the ground so that it could calculate when to fire the rad rockets. The rad rockets fired, and we hit the ground, and for a brief instant we saw an intermittent signal, and then the lights went out. And while everybody was jubilant that we'd gotten that far and so well, there was no signal from the craft at all. And this was somewhat expected because we would be bouncing across the countryside, covering as much as a kilometer along as we bounce, and we allowed ourselves 10 minutes of that bouncing before we would feel that we were finally at rest and we could send back confirming tones indicating the state of the system. Well, sure enough, it took a little longer than that, but we did get those tones, and now both Goldstone and Canberra, stations of the DSN, are in solid lock with the X-band direct-to-earth signal from Spirit.
So strong confirmation. It's there.
Yes, yes.
And the other thing that I noted was they mentioned they received a tone bass pedal down.
Ah, I'm glad you heard that, because I was trying to sift that out of all the noise in this room. But that's very good news. That'll make opening the pedals during the next 45 minutes. That'll make that a fairly simple operation. That's how we would hope it would land.
So it may mean good news for perhaps the Odyssey Pass, that maybe these deployments and these things that we need in order to have UHF communication to Odyssey may happen when we need it to happen.
That's exactly right. The other report that came in was from the MGS MOC, that's the Mars Observer Camera crew. They received the UHF data during entry, descent, and landing, and they have a lot of data to provide us. In fact, that's being played into the real-time area as we speak.
So what are you looking ahead at then?
Well, let's see. It's going to take a while. We have to retract the airbags, and we're going to take as long as we need to do that, because that's critical for this mission. We have to get the airbags deflated and out of the way. We then open the pedals. The pedal operation will take some time, but not all that much, maybe 12 minutes, 15 minutes. I hope I'm remembering these numbers right. And after the pedals are open, we deploy the solar arrays. This is the critical deployment phase. We have to get the solar arrays out so that when the sun rises in the morning, they'll have power. If we don't, the mission is over. So the solar array deployment is critical. Assuming that goes well, and so far everything's gone well, but assuming that goes well, we'll deploy the PanCam mast assembly and start taking some pictures of our landing site.
So would there be a possibility that we get pictures even tonight?
Yes, there is a possibility. I don't want to get out ahead of this. You know, you can only hope for so much luck. Right. But I'm sure we're going to wait around.
All right, so we have best case scenario tonight.
So far.
So far. All right, thank you, Chris. Thanks for walking us through these key moments. It's been very, very exciting. Let's go ahead and recap these events so far. The Mars rover Spirit has indeed landed on the surface of the red planet. We have indeed heard from it. That is very good news. Congratulations to the flight team. The next event here on NASA TV will be a news conference. It is scheduled at 9:30 p.m. Pacific time. The press conference will be followed by more commentary at 11 p.m., at which time we hope to communicate with Spirit through the Odyssey orbiter. That's it from Mission Control at the Jet Propulsion Laboratory in Pasadena, California.